This is number 8 off of the Unit 2 study guide. This is the question where we're looking at a linear model of some data. In this case, it says that I took a survey of 14 randomly selected students to determine the relationship between the amount of time they spent studying for an exam and their score. And says she, I guess I should have changed that to he. I found that a linear relationship exists between the two variables. The line of best fit that describes this relationship is y equals 5.225x plus 58.085. So theoretically what happened is I got my 14 students and I paired up the number of hours they studied, which was x, right? X was hours studied, and y was their exam score. So I had these 14 different ordered pairs of how many hours a student studied with the exam score. I put those into like a spreadsheet program like Google Sheets. I had it make me a scatter plot, right? So I had this, maybe I had this scatter plot that looked something like this, where I had all these dots where it's basically showing that as the hours went up, the score also went up. And the scatter plot found, hey, there's this line of best fit that looks like this. And then that line right there had the equation y equals 5.225x plus 58.085, right? So that's what this is saying happened. So now we're going to use this linear model to do a few things. First, we're going to predict the exam score of a student who studied for 2 hours. So what that means is maybe we didn't have a student that studied for 2 hours, or maybe we had a student that studied for 2 hours and got a certain score, but according to our model that came from our data, what is our model saying this student should get? So that is, remember, that is an x value, because x is the hours studied. So we're going to take that x value, put it into our model, make it say y equals 5.225 times 2, plus 58.085, and we're just going to evaluate that. So we're going to take our 5.225 times 2, grab a calculator real quick, 5.225 times 2, and that's going to be 10.45, and that gets added to 58.085, 58.085, and that gives me a score of 68.535, which we could say is about 68.5%. That's what would be the predicted score of a student who studies 2 hours. The next question says, interpret the coefficient or the slope. Remember, coefficient is a number in front of a variable. That is like the definition of what a coefficient is. So if we look at our function, y equals 5.225x plus 58.085, that 5.225, that is the coefficient. So what does that coefficient mean in our model? Well, every time I increase this value by 1, then this number is getting another 5.225 added to it. Or we can think about that the slope, right? The coefficient stands for the slope. That is rise over run. So every time we move over 1 on hours, we're going up by 5.225. Because look, it says 5.225 over 1 is our rise over our run. So every time we go 1 hour over to the right, 1 to the right, results in 5.225 up, or an increase in 5.225 on the score. So what this means is that for every hour studied, for every 1 hour a student studies, their score should go up by about 5.225%. And that's what that coefficient means. Now the next question, let me scroll down here a little bit. The next question says, predict a score for a student who did not study. So again, our model was y equals 5.225x plus 58.085 was was our function. If the student did not study, right, did not study means that the x is equal to 0. They spent 0 hours studying. So we're going to say y equals 5.225 times 0 plus 58.085. Well, that's just going to go away, right? This is just going to disappear, the 5.225 times 0, and we're going to have 58.085, or we'll say about 58.1%. Finally, the last part says a student who studied 6 hours for the exam scored an 81. Is this student's exam score above or below average? And explain and show your work. So if they studied 6 hours for the exam, that means that in our model, the x value is going to be 6. So we're going to take our y equals 5.225x. We're going to put a 6 in, plus 58.085. So 5.225 times 6 is 31.35 plus 58.085 is going to give us a score of 89.435, or about 89.4%. But that's what they should have gotten, right? This is the predicted score. Predicted score. Actual score was 81, right? 81% was the actual score. So the question asks, did they score above or below average? Well, they were predicted to score an 89. They only scored an 81. So I will say, therefore, the student scored below average because they were predicted to score 89.4%, but only scored 81%. And that would be my explanation. And here's my work that I showed.